In this chapter, we will give an introduction to one application domain where Simulink is used. We will show techniques for modeling a water treatment plant. This unit is not intended to teach lessons on water treatment. The time that we've got for this chapter is by no means sufficient to do that. And also, I'm not an expert in water treatment. We will use the application domain of water treatment to teach how modeling techniques are applied to this application domain. The water treatment plant serves as an example to permit you to implement a more complex and more realistic model than we employed in the introductory chapter. However, the model we will develop here will still be very much simplified and incomplete with respect to the complexity of a real water treatment plant. Moreover, all parameters are estimations and cannot be used for designing a real water treatment process. The first thing that we need to specify when we start modeling is the parameters that describe our medium that is treated during the process that we want to model. Of course, this medium is the water that is treated in the plant. But how is this water described? What are the relevant parameters that make up the quality of our water? In every country, there are legal regulations that specify which parameters of the water have to be checked and which maximum permissible values have to be maintained in order to qualify water as drinking water. In the European Union, for example, such regulations are described by a directive issued by the Council of the European Union. Now let's have a look in detail at what the relevant parameters of our water are. The first parameter is the sand concentration of the water, as well as the sand's grain size. In flowing water, there is always some fraction of sand that has to be removed during the treatment in the water treatment plant. For the treatment of the water in the plant, the water's mass density is also relevant. Of course, we have to model all the components of the water that we want to get out of it during the treatment process. Finally, we have to model the water's turbidity, and we have to model how much water flows through our plant. Typical values for these parameters in untreated or raw water can be seen on this slide. These parameters, except the volumetric flow rate, are typically modeled as constants, as you see on this slide. For modeling the volumetric flow rate, I suggest modeling the maximum flow rate as a constant and modeling the actual flow rate as a fraction of that maximum flow rate. The fraction is determined by a slider gain, and the actual flow rate is the product of the maximum flow rate and the value of the slider gain, as seen in the lower part of this slide. Now that we know which parameters we want to model, we can have a look at the signal processing steps that are necessary to clean the water so that when it leaves the plant, it is potable water. In this video, you see the single elements of such a water treatment plant, and we'll just have a brief look at these elements. At first, the water enters the grit chamber. Here, sand and grit that is transported with the water sinks to the ground. Afterwards, the water is treated in the coagulation basin. Here, a flocking agent is added, and the water, including the flocking agent, is mixed thoroughly so that flakes are built. The next process step takes place in the sedimentation basin. Here, the water does not move much, so that the flakes that have been built in the coagulation basin sink to the ground. Thus, dry matter is removed from the water. In the following sections, the grit filter that is coming into view here, and the activated carbon filter that we are seeing here, further steps are performed to remove dry matter and organic dry matter from the water. Finally, in a disinfection stage, using ultraviolet light, bacteria inside the water are eliminated. The ultraviolet disinfection stage is seen here in this area. In this chapter, there will only be one exercise at the end of the chapter. The exercise will be to implement a simplified model of a water treatment plant as it is described in this and the following units. However, in order to break this exercise down to smaller pieces, in every unit we will present some part of the exercise related to modeling the subsystem that was treated in the respective unit. For the actual exercise at the end of the chapter, we will show you the slides containing the single sub-exercises again. For this unit, the sub-exercise is to build a Simulink model that represents the water parameters described in this unit as a bus, as you can see it on this slide, and how it is summarized here.